Look, so you have given 0, 1 matrix. The question number is 542. Let's read the question first. You have given n into m binary matrix. Binary matrix means it contains 0 and 1. We get the distance of the nearest 0 for each cell. So we have to find the nearest 0 for each cell. And distance between the two cells, a common base is 1. Okay. So what they are saying, let's take this one. This is, so you have some array TP. I think matrix of 0 into 0, not array. You have some matrix. You have uh, either 1 or 0 as a value of the cell. So if you see this cell, the nearest 0 for this cell, it's again, it's itself a 0. So nearest 0 will be same. So it's a 0. At 0 distance, the nearest cell is 0. For this, it's itself as a 0. So nearest distance will be 0. This 0. It itself is a 0. So nearest distance will be 0. If you see this, it's itself a 0. The nearest 0 itself is a 0. If you see this 1, if you see nearest 0, it can be this, it can be this, it can be this, it can be this. Okay. So what I am saying, like for finding the nearest 0, you can go either this way or this way, this way. Both are on a distance 1. So nearest 0 will come at a distance of 1. Okay. If you see this 0, again 0, because it itself a 0, it itself a 0, it is itself a 0. Let's take a different example. Okay, let's take it 1, 1, 0, 1, 0, 1, 1, and this is 0. Okay, we will make distance will be here. Okay, we will like write the distance will be. So for this, so if you're calculating by one, it will create error. So it will like make it confusion or it will difficult for you to get the value. So first we will do whatever the zeros we have in the cell. We'll pick that zeros. This one is 0, this one is 0, this one is 0. Okay. So nearest 0 for these values will be 0 because it's itself a 0. Such a 0, 0, and 0. Now we move either up and down any place. So if we move it for this one, what will the nearest 0? This at a distance of 1. So distance will be 1. For this one, what will the nearest 0? This at a distance of 1. For this one, what will the nearest 0? This at a distance of 1. For this 0, what is the nearest distance? Is 0 is 1. For this nearest is 1. For this nearest is 1. So this is the final matrix. You have understand? So first what we do, we just pick where the zeros we have, and from there we move one by one. If it's like this, so let's assume like we will go like this. Where's my code? Yeah. Let's understand one more problem. You have a question containing 0 and 1. Same matrix here I will put 1, 0, 1, 1, 1, 1, 1, 0, and this is 1. Okay. And here we will answer the distance matrix which we need because we have to find the nearest 0. So what I've said, just find the nearest 0 first. Because from there, if you move, it will easy for you. Make it 0. Because it itself is 0. So distance from 0, nearest 0 is 0. For this also 0. Let's take this one. Nearest 0 will be after this side is same distance 1. If you go for this same distance 1 at the top. If you go for this, let's before you can go for this. It's again a 1 because it is nearest also. But if you go for this, now what will the nearest distance? So you can't move like this. You have to just move up this, and down. Fourth side you have to move. Okay. So if we at one, then what will the nearest possible? You had either have to go like this and then move this. So two distance, or either you go like this, do two distance, either you go like this, two distance. So minimum, the nearest one will be at two distance. So here we put two. Now, if you see for this, what will be the nearest distance? If you go this, three distance. If you go and this, three distance. If you go this, three distance. So it will create a three. For this, if you go like this, two distance. If you go like this, two distance. And for this one. So you got my point. So first, what we do, we just find whatever zero we have. If you call for the nearest zero, whatever zero we have, we take this. We can move one by one on their child. So these are the child of this. We move this one. So whatever at this child distance, it has one. If it's not, it is at a distance of one. If it's not zero, then it is at a distance of one. Okay. Then if you move the child of this, because it has distance from zero is one, then it again has a distance of one. So what distance become? It's two. So what I'm saying, if you had zero, let's suppose you have child one and two, like one and zero one you can take. You can move to down. You can move. You can say if you have zero one, you can take as zero one. Okay. So if someone like if one is there, so you are here. So this element has child this two child there. So for this value of 1, what will the nearest distance? So we reach there with a distance of 1. If you're reaching there, then we just add the distance 1, then it becomes 2. So you got my point? Like what do I do? We just do the BFS. We just store whatever 0 we have. Then we will increase the distance 1 by 1 if we are going their child. So whenever we are going down to their child, we'll increase that one. If we are getting not 0, points should be noted, not 0. But I think we are not getting 0 because we first time it only stored the 0 values. So I think it will now be, and we will check if it's visited or not. If it's visited by some, then why we are not checking? We are not changing the value because if it's visited, it will be the nearest possible base. Okay, so we are not doing this. So let's go to the answer. So we have some matrix. So we will just find first n and m. So we will put m. This is mat dot size. Now we will find m, which is mat dot size 0. Got my point. Okay, so we need two things. One is fidgeted and one is distance array we need to and give the distance array. So first we will make a visited array, vector int int. You can take as a visit and so visit and comma vector and then and comma 0. Okay, and say we copy just and then we just paste. And this is a distance. This recognize the distance. So distance. Okay. What I'm said. First we will find the 0. I equals to 0, I is less than m, I plus this. Then again we have to find m j equals to 0, j is less than n, j plus plus. Okay. What I have said is net of I and c is equals to 0. That means we got our 0. So we will push in the queue. So we need queue. Now we need to such that it will store the both. So we need queue which store pair, and inside that we again have a pair int comma int, and this pair is int. But so this pair will contain ing, and this will contain the distance, what the distance value were. So if you see what we can push we can say I comma z, and what we're pushing the distance 0. So this we are pushing, and we have visited this. So we will make it visited to I say equals to 1. We make this. Okay, so now we will add it to the queue. So if queue is not empty, we will add it to the queue. Okay, that's great. We will find first row which will be the queue dot come. The first we will find then then the first int column equals to queue dot and dot first dot second second. Okay, and this you can say q dot count dot second. Okay, so this I will got. Now I will mark this row and go where we can just okay, so I will mark this distance of this new whatever we are getting. So columns whatever with this we are getting. Okay. Now we'll add to the info ID added to the matrix state child. So if we add it to the child and how we can add it, we need four direction. So can we take like this in D row, which will be -1 0 0 comma 1 and in the column k is equals to 0 0 1 -1 and 0. Okay, so we'll iterate all the four sets with any times. With 4 int I equals to 0, I is less than 4, I plus plus, getting new rows. So if you're at distance, then if you see what I'm doing, so if you're at any distance, like at any rows, so let's say you are this row column. So if you move, what you do, you just add with one, column will be same. So minus with one. If you move here, what we do, row will be the same, column will decrease by one. If you move here, what will do, we will increase the row, but column will be same. If you go here, what will do, the row will be same, and column will be add. So if you see carefully what the value we are adding. So if you're moving here, what value are adding? V 0 minus 1. If you're moving here, what are value we are adding? 0 minus 1, 0. If you're moving here, what value we are adding? 0 and this is 1. If you're going here, what value we are adding? 0, oh, sorry, 1 and 0. These four values we are adding. So we are adding, we are just having these values. So minus 1, 0, 0, 1, 0, minus 1, 1, 0. Yeah, you got this thing? Yeah. Okay. Change the semicolon then. So my new row will be whatever row, we will add this d row of I and in new column will be whatever column, big column, and I. So remove whatever size. Then we have to check what we have to check. It should be within our matrix. So it should be greater than equal to 0 and new cross it less than 0 and new column so greater than 0 and new column so less than, so it's m and it's n. It's m and it's n. And it should not be visited. Row so this is 0, so it's not if it's not visited, then what we're doing just is acting and add the distant power. So we make it visited, new row, new column goes to 1 and we push in the queue. Okay, what we're pushing, we're just pushing new row, new row, column, new column, so new row, column, new column, and we're just pushing new rows, column, new column, with the distance which we have this plus 1. Okay, so we present this, then we need to call this, let it to this, and we return to this matrix related. So let's see the code first, and then we have matrix outside where and vector size we have written we want take visited where take distance where int command this below this below this below. Okay, we will take the matrix as 0 because to find the nearest 0 make a distance. I have make a distance 0. Okay, we move all the four sides. We have 20 first, second will column. This will be the distance. Okay, again pop out. To remove that things which are not. So pop out. Then give this distance. We matrix with the four rows and it's will be this, and this, and this. And this, then remove distance plus 1 and this charge. Let's send this. The column, what I have written this. Okay, so we are getting a correct answer. Let's submit this as okay. So we will discuss about the time complexity. If you see the time complexity of this question, time, mm, so what we are doing is first move down till here. I think it's okay. We will get the okay. So here we are running order n into n time complexity. Here again we are running n into n and we are checking for the key also which is a 4 times we are running. So if you see the time complexity will be order n into n. Let's take about the space complexity which will be this one which is m into n order of m into n plus this one order of m into n. We're taking and anything we're taking and we are taking a q which is also m into n. So basically it's m into n of the space complexity and this is a time complexity. So this ends. Thank you.